Industrial process plants contain many types of systems, and they can be very complex. One of the best ways to find your way around a system is by following diagrams. The information contained on plant diagrams can help you understand how the systems in your plant are laid out and how they operate. Since diagrams generally pertain to specific systems, some of the examples you'll see in this unit won't be the same as the diagrams at your plant. But many symbols and methods of reading diagrams are common to nearly all diagrams. So this unit will give you a good foundation to start from. In your work, you may use a couple of types of diagrams to locate equipment in your facility. In this part, we're going to concentrate on two of the most common types: equipment arrangement diagrams and elevation diagrams. We'll start with an equipment arrangement diagram. An equipment arrangement diagram shows locations for pieces of equipment. Each type of equipment is represented by a symbol. For example, these symbols represent pumps, these represent motors, and these represent tanks. When you compare the symbols with actual equipment, you can see that the symbols are similar in shape to the equipment they represent. Equipment shown on diagrams is usually labeled with its name or equipment number, or both. For example, a pump may be labeled P31A for pump number 31A. Some diagrams may also show the distances between equipment. Another diagram that shows equipment locations is an elevation drawing. An elevation drawing shows where equipment is located on different levels in a facility. Looking at an elevation drawing is like removing a wall and seeing a side view of the equipment on different levels. The location of each piece of equipment is shown in reference to a measurement called an elevation. Sea level is commonly used as a reference or starting point for elevations because ground levels can change. Drawings and diagrams that represent parts of a system and the flows between the parts are referred to as system diagrams. We're going to look at three types of system diagrams: block diagrams, piping system diagrams, and electrical diagrams. And we'll start with block diagrams. This is an example of a simple block diagram. It illustrates some of the basic parts that all systems have. The blocks represent the energy source, devices that perform a control function, and load or demand in a system. The lines represent the transmission paths for material or energy through the system. This block diagram is a process flow chart. The boxes represent pieces of equipment in a chemical process, and the lines represent flows. This type of diagram is often used to describe a process system. Piping system diagrams provide more detail than block diagrams. This diagram is a kind of piping system diagram called a flow diagram. It uses lines to represent process flows and symbols to represent process equipment, including tanks, pumps, and valves in the system. But a flow diagram doesn't show the devices used to monitor the process or all of the devices used to control the process. A piping system diagram called a piping and instrumentation diagram, or P&ID, like this one, is used to show how a process system is monitored and controlled. A P&ID shows material flows, equipment in the system, and the devices used to monitor and control the system. The last type of diagram we'll look at is an electrical diagram. Electrical diagrams show the components and connections in electrical systems. Like flow diagrams and P&IDs, electrical diagrams use lines to represent flow paths, in this case the flow paths for electric current, and symbols to represent equipment in the system. In addition to showing the equipment and connections in a system or process, system diagrams usually include other information on how to interpret the diagram. This information is contained in title blocks and legends. A title block is used to identify the diagram. It usually includes a description of the diagram and an identification number. It may also include additional information about the diagram or the system it represents. Legends generally give the meanings of the symbols, abbreviations, and prefixes used on the diagram. In this topic, we saw some of the basic types of diagrams used in process plants. System diagrams can help you learn about the systems in your facility, and equipment location diagrams can help you locate specific pieces of equipment. Try some questions now to check your understanding of these types of diagrams. An equipment arrangement diagram shows locations for pieces of equipment. Each type of equipment is represented by a symbol. For example, these symbols represent pumps, these represent motors, and these represent tanks. A piping system diagram called a piping and instrumentation diagram, or P&ID, like this one, is used to show how a process system is monitored and controlled. A P&ID shows material flows, equipment in the system, and the devices used to monitor and control the system. A good way to start reading any type of diagram is to become familiar with the symbols on it. So we'll take a look at some common process flow diagram symbols and the equipment they represent. This is a flow diagram for a mixing and dilution system. These symbols all represent tanks. The symbol for a mixing tank includes a motor and mixer blades. Diagram symbols are often drawn to represent a certain view of the equipment they represent. For example, if you compare this symbol for an acid tank to the actual acid tank, you can see that it resembles a side view of the tank. This stair-step symbol is used to represent a positive displacement pump. Positive displacement pumps are designed to move a specific amount of liquid on each stroke. The other pump symbol on this diagram represents a centrifugal pump. Centrifugal pumps move liquid by applying centrifugal force to the liquid. The flow rate through this centrifugal pump is controlled by a valve in the piping on the discharge side of the pump. In this case, a globe valve with a pneumatic actuator is used. Globe valves are often used to regulate fluid flow because they can be partially opened or closed to adjust flow rate. You may see globe valves represented on diagrams by either of these symbols. There are 3 globe valves, one in each line to the dilution tank and one in the line to the storage area. Another type of valve in this system is a gate valve. Gate valves, like this one at the bottom of a tank, are normally positioned fully open to allow flow or fully closed to isolate equipment. The symbol for a gate valve is similar to the symbol for a globe valve. This symbol represents a check valve. Check valves are designed to allow fluid flow in only one direction. There's usually some type of notation on the valve that indicates the direction of flow through the valve. For example, flow through this valve is in this direction. The dot on this symbol indicates the side of the valve where fluid enters, so flow would go through the valve in this direction. This is another symbol you may see used to represent a check valve. It uses an arrow to indicate the direction of flow. The final valve symbol used on this diagram represents a relief valve. The relief valve opens when system pressure exceeds a preset limit to vent fluid from the system. If the pressure continues to rise, the valve opens further. Once pressure returns to normal, the valve closes automatically. This is a typical symbol used to represent a relief valve. You may also see it represented this way. We've looked at the symbols for all the valves used in this system. Other systems may use other kinds of valves. For example, many systems use safety valves to relieve pressure. Safety valves are designed to pop open when system pressure exceeds a preset limit and stay open until system pressure drops below the pressure at which the valve is set to open. This is a common symbol used for a safety valve. You may also see it represented this way. Another common type of valve used in process systems is a butterfly valve. Here is the symbol for a butterfly valve. The dot on the symbol represents the valve stem. The slanted line represents the valve disc. It takes only a quarter of a turn to move the disc from fully open to fully closed. Ball valves are similar to butterfly valves because they take only a quarter turn of the valve disc to go from fully open to fully closed. A ball valve has a ball-shaped disc with a hole through it. Ball valves are also sometimes represented using this symbol. The symbols for the valves and other equipment on a process flow diagram are connected by lines that represent the flows of materials in the system. Lines that cross with a hump or a break in one line represent material flows that are not connected. Lines that cross like this, without a hump or a break in one of the lines, represent flows that are connected. The same material flows in all 4 legs of the piping. Some diagrams include codes which indicate piping diameter, or the piping material specifications. The codes are helpful in locating and identifying specific pipes in a system. Well, we've covered a lot of common symbols so far. Many fluid systems you work with will have tanks, pumps, and valves. Process systems typically contain more valves than any other kind of equipment. Some are operated manually with a hand wheel or a lever. Others are operated by devices called actuators. The most common actuators are pneumatic or air-operated actuators, motor-operated actuators, solenoid-operated actuators, and hydraulic actuators. The symbol for a pneumatic actuator resembles the side view of an actuator. The other symbols consist of a box containing a letter designation. Some common designations are M for motor, S for solenoid, and H for hydraulic. Here we've used a gate valve symbol to show how the combined valve and actuator symbols would appear on a diagram. If an actuator isn't shown for a valve, or if the actuator symbol looks like a T or an upside-down L, it means that the valve is operated manually. In many processes, heat is transferred from one fluid to another at some point, so these processes usually have at least one heat exchanger. Depending on the application, heat exchangers can heat or cool a process fluid. Let's look at an example. In this example, steam is used to heat a process fluid. The process fluid flows through the tubes in that heat exchanger, and the steam flows through the shell around the tubes. As process fluid flows through the heat exchanger tubes, heat from the steam flowing around the tubes is transferred to the fluid. This is a straight tube heat exchanger. These symbols are often used to represent a straight tube, shell and tube heat exchanger. This symbol represents a U-tube, shell and tube heat exchanger. You may see this symbol used to represent either type of heat exchanger. Each of these symbols has lines that represent the inlet and outlet for the two flow paths through the heat exchanger. One pair of lines represents flow through the tubes in the heat exchanger, and the other represents flow through the shell around the tubes.